Good morning, good morning, good morning, people. How are you doing? It's Chris with Croft CNC. We're doing coffee and cuts in the morning. It's 11/20/2020. So got a good show planned. I actually took down notes and we'll start going through some stuff. This morning I'm drinking what am I drinking? Black Rifle coffee, Freedom Blend with some a tablespoon of raw honey and a little bit of cream. So no whiskey in this morning. It is Friday. I should have some, but I got work to do. Okay, let's get into this bad boy. What's up, guys? Copperhead Metals checking in. We got Tim Pugh from Old School Classic Customs down in St. Mary's, Georgia. We got John Gallant. So we got Taser. We got Matt White. And a repost from Tim Pugh. Right on. For those of you that don't know, Tim is my uncle. He's the retired Command Master Chief that I talk about. Him and my father kind of shaped me into the discontented human being that I am. This is a great morning. It started out as a rough one. I'm still not completely wide awake. I kind of died last night. I got home. It was like 9:30. I crawled in bed. I got a 25-pound weighted blanket that I sleep with, and I absolutely love it. Crawled under that thing to watch TV with my wife and daughter in the bed. And next thing I know, I wake up. It's like 6 o'clock in the morning. Throughout the night, I had a couple people call me looking for machine help, and I'm like, not tonight. So I tried to get some good sleep. It was just one of those things that I just had fun with. There's nothing like a good night of sleep. Set up yesterday. Was pretty excited to set up for our first show of the year. Wow. We're sitting there trying to figure out how we're going to keep business moving in this day and age for small businesses. And that's kind of the segue into the first question I wanted to address. Actually, the first question was, what coffees do I like? I like medium to heavy coffees. I like something with some flavor, but I like it to have a bite. And then I also like to make coffee mixes. One of the things I do a lot of is I mix Tullamore Irish whiskey. I do a 1 ounce shot of that to a 6 ounce cup of coffee. Typically, I like to use Dead Man's Reach from Raven's Brew. And what I'll do is I'll take 3 sugar cubes, throw in the cup. Actually, let me back up. I make Irish coffee, Buena Vista Irish coffee at home. I lived in California, came back here and didn't have it, so I learned how to make it. The setup's pretty simple. I take hot water, I take boiling hot water, pour it in my cup, let it heat up the ceramic of the cup, pour it out, 3 cubes of sugar in, 6 ounces of coffee in, 1 ounce of Tullamore whiskey in, hand whip heavy whipping cream, and I float that over the top. You drink the hot coffee through the cold cream, cools off the coffee, and at the end of it, your sinuses are open, your wide awake and you feel like you're ready to take on the world and put up with a whole bunch of bullshit that you don't have to. So that's actually my favorite coffee, is actually a coffee mix. So we can go ahead and cross that question off. Look at that. We're already productive this morning. How do I like my coffee? That's 2 questions answered in one segment. How do you like that? Okay. This question I got last night while I was setting up. I did a long live from the venue. We're doing Winter in the Woods at Dunkled Acres in Southeastburg, Pennsylvania. It is it's a beautiful venue. It's kind of out in the middle, right on Matt Taser, White, Black Rifle. You got to try some Ravens Brew Dead Man's Reach or Double Dead. Anyways, I came live from the venue last night and I showcased my booth, but then I also showcased everyone else's booth. Okay. And I did that for a specific reason. My job, as I view it, is not to just sell my wares. My job is to help everybody sell their wares. I have a following that watches me when I do lives. I have a following that watches Coffee and Cuts. I love showcasing other businesses because it gives me ideas for my business. So when somebody sends me a message, why do you showcase other businesses on your live? I want to see your products. You guys get to see my products. You guys get to see me make my products. Okay. What you don't get to see is the mom and pop retired couple that the guy is out there woodworking by hand and the lady is hand painting the products he makes and then trying to sell them for $10. Like, they're not even recouping costs out of that. And I feel like my way of helping them with that is to showcase their wares so that they can sell more of their wares, right? It just seems like good business. Like, for me, I don't know what it is. I really don't. I want to see everybody make it if they're willing to put in the effort. If you're not willing to put in the effort, I don't care about you. I don't care. I just wish I could say something else, but I can't. Like, I just don't care. My give a damn is broken when it comes to people who, woe is me. Oh, I can't do this and I can't do that. Like, there are so many other people out there with so many heavier problems than what you have. I don't feel bad for you. Sorry. I'm really not, but it sounds good. So that kind of is why I showcase other businesses. I'm not a commune hippie. Everybody has to have equal. I believe in the people that put forward the effort need to be recognized, and they need to have a solid shot. Maybe those older people don't know how to use their social medias or don't have social medias, and I might be able to bring that to the masses, and it might actually change their life. I don't know. I can tell you that for me, people believing in me and people following me the way that they do has changed my life. Whenever I'm down, it picks me up. Whenever I'm up, it makes me work harder, and I try to do that for them. And that's all there is to it. So look at that. We're flying through these questions. I got to slow down or I'm not going to have a live show today. Another thing, I've been getting some questions. I get this probably 1 to 2 times a day. Okay. Um, it is, it's like 3 questions, but it's the same question. Uh, I want you to try my coffee. How can I send you coffee? How can I send you machine parts? And how can I send you a donation? All right. I don't do this for donations. All right. If you'd like to send donations, you are more than welcome to. I will showcase them on the show. I will give you a shout out. However, I do not do this for donations, so do not feel obligated to do anything for me. That's not why I do this. I do this because I've got some stuff going on in my head, and I want to puke it out, and I just want to get it out there. And if you like watching it, you like watching it. But if you want to send me coffee, you can send it to the business address on our Facebook page. It is 1020 West 4th Street, Lock Haven, PA, 17745. Address at the Croft CNC, care of Chris. Machine parts, same. Monetary donations, you can send it to our PayPal, which is croftcnc@yahoo.com. Okay. I can tell you I love coffee. So if you send me coffees, I'm there. I love machine parts. If you want to send me a machine part and I can try and figure out what it is, I can try and figure out a way to repurpose it, whatever the case may be, I'm there. Let's do that. Monetary donations, like I told you before, I'm not really big into money. Money makes the world go round. I can buy more machines with more money, but I'm not worried about it. I would rather have the machine parts and the coffee. We've had luck being sponsored by machine companies. We have a company that sponsored us a CO2 laser for retrofit. We've had 2 separate diode laser companies sponsor us. Our very first sponsor was Jay Johnson from JTech Photonics. He sponsored a 7-watt laser, full laser kit. We also had George F from Endurance Lasers wanted to sponsor a laser. So he sponsored a 10-watt diode laser. What else? We've been sponsored a couple different things. We were sponsored a 4x8 rack and pinion machine from CNC for Newbies. We were sponsored a full X-Carve upgrade kit from TBD CNC. They went above and beyond whenever it came to upgrading the X-Carve CNC router. And then that paved the way, and we were able to, hey, I got an upset face. I got a Facebook angry face. Who the hell sent me a Facebook angry face, and why? What is the purpose of that? Let's see here. I got to turn that down or you guys are going to get feedback. Okay, let's see here. Yo, Fat Fingered Tim, why'd you give me an upset face? We're going to have issues. That's all. That's it. We're done. We're fighting next time I see you. I'm going to kick you right in the ding-a-ling. Anyways, we really are excited whenever we get sponsors because it's new stuff to try. I have never played with an endurance laser before, and George sent us one, and it's different than any other diode laser that we've come across. We've had the El Cheapo laser. We've had a cheap Chinese diode laser, and the driver systems for those are inexpensive. They're made to be the most inexpensive that they can be. With George's, there's a rocker switch on it. There's a key lock out, and then it's pretty intuitive after that. The JTech is a switchable driver. It has a push button reset, a key lockout, and it's pretty intuitive after setup. The CO2, I'm working with Russ from the Tangerine Tiger Project on YouTube. If you check him out, I can't remember what his thing is right now, his handle, but if you search Tangerine Tiger Laser, he'll pop up. He's actually helping me with the retrofit on my CO2 laser. So we'll have a CO2 laser up and running here within the next month or so. That one we are, I'll mark that down. That one we are looking for sponsors on. It's for the retrofit. It's going to cost me about $500 out of pocket. If you guys know anybody that wants to see a set of retrofit videos on that, please, it's an Epilog laser, and we're going to retrofit the LPT printer port to a new USB printer port, probably a Rowita board, and go from there. Let's see here. We got Tim Pugh dropped this phone. That's how I ended up with the angry face. He's got fat fingers, but they're small. They're like sausage fingers. They're like little people fingers, you know. He eats a lot of bacon. They get greasy. It's really weird looking. How's that for you? Huh? Come at me, bro. Let's see. John needs some ideas for some oak wood projects. We will go over that in a little bit. Let me write that down. Project ideas oak. Okay. So in any event, we're going to try that retrofit for that Epilog. That is something I have yet to do, is retrofit an Epilog laser. I've retrofitted K40 lasers and stuff like that. They're pretty easy, but I've never retrofitted an Epilog because they're quite expensive lasers to just play around with. You know, we try to do stuff and bring you stuff that's within my wheelhouse of cost. So that's one of the next projects. The X-Carve, we've pretty much taken the X-Carve as far as it can go as an X-Carve. The last upgrades for that are going to be dual ball screws and linear guide conversion, or a rack and pinion conversion. But by the time we do that, we no longer have an X-Carve. Like, we're at the very end of what an X-Carve is at this point. So we're pretty much going to do away with the X-Carve, it'll be referred to as the Supercarve. And being that I replaced the gantry, I no longer have the X-Carve branding on it. The X controller is no longer on it, so it is not going to be an X-Carve anymore. And that pretty much will wrap up that project. That's been a 3-year build, and just different things kind of being put into it, and I really enjoyed that one. So those are some things coming up that if you guys know of anybody, the only other big thing that we really would like to get some sponsorship on is the only other big thing will be the plastic recycling system. I priced it out. It's going to be about $7,000 for the machines that I need. And basically what I want to do with that is I want to take and recycle any and every plastic that I can get a hold of, plastics 1 through 9. And I want to recycle them. And I want to make plastic bricks. Ooh, got a whistle there. But I want to make plastic bricks that will be able to be filled with clothes, maybe clothes that don't fit, maybe stuff that it's not suitable to be used for Goodwill, and you have too many shop rags or anything like that. You could take clothes, put them in these plastic bricks, put them in your wall, and now you have an insulation value. You could take the plastic, we can make solid plastic bricks and make an insulation value to go in a shop, and then also make a press that can cover the walls. So basically just a plastic 1/4-inch sheet that covers your walls, and it'll be an easy way for us to help outfit shops and stuff like that with recycled materials, kind of taking a bite out of the impact on the environment, but giving a useful application after the fact. Once again, I'm not into this hippie stuff, but I'm all about making something out of nothing. And that's one of the big projects in 2020. I want to have that up and running. I have access to as much PET plastic as I want. And let me tell you, there is a lot there. So yeah, that's that. Let's see. We got some comments rolling in here. John says, "How are you feeling these days?" These days I'm feeling tired. I'm still having chest pains, lightheadedness, passing out, but the gallbladder pain is gone, thankfully. That was pretty horrible. Now the only thing is to figure out why I'm passing out and get that taken care of so I can get back to driving and doing my own thing. All right. Matt, could you laser etch panhead aluminum engine covers? Okay, so the lasers that I have will not laser etch metal. If you want to laser etch metal, you need what's called a fiber laser. There are coatings you can put on the metal to laser etch them with a diode or a CO2 laser, but it's not actually eating into the metal at a substantial depth. Okay. It's a different process. It's a different all around laser. You need what's called a fiber laser. It's a fiber optic laser. It puts out a different wavelength, a much higher power. They use a much higher power source. what I do right now is I use a product called Spectra Coat. Um, and it is by far one of the best metal coatings for laser etching that I have come across. Um, I don't say that lightly. I've tried everything from mustard to your run of the mill um, Cerakote or not Cerakote. What the there's another one out there like Spectra Coat, Chemcoat maybe. I'd have to look at the bottle, but basically it's an aerosol you spray on it. It it reacts, and whenever it reacts, it etches into the metal some. It's almost like acid etch primer. Um, so you end up with something that marks it, but it isn't great. Um, my diode lasers will etch into it, but it's so slow that, it'll take 10 hours. I mean, you got to move at like 5 inches a minute, perfect focus, and go from there. Um, the fiber lasers are like, for a good one, you're looking at like $7,000, which isn't bad. I'm not saying that, but for a small business of my caliber, um, it's not really in the book right now. Maybe in 2021, if things pick up, it will be. Um, but that's why I made the impact engraver, and I have the diamond engraver. Is the diamond tipped engraver is because that's what I use to etch a lot of my metals. My impact engraver does a hell of a job at engraving in metal, doing a deep engrave, and I do it at about 10 thousandths a pass, and I can go a 16th of an inch deep in it with no problem. And that doesn't seem like much, but that is a lot. When you're talking about machining into metal, that's a lot. That's deep. I've been able to do metal like um, light sledgehammers, the hexagon on them. I line those up and do scroll pattern work on them and stuff like that. And then I'm able to antique it, and it looks really good. So that's kind of my workarounds is coat the metal, or engrave the metal. So yeah, there are ways to do it. We can do it, and whatnot. So, okay. One of the questions I've been getting, two or three people have asked over this past week was, what is your favorite machine to use? I gotta be honest. I sat down and I thought about this for hours. I've really racked my brain on which one is my favorite machine to use. And I don't have one favorite machine to use. I enjoy the process. I enjoy building the machines, and I enjoy using the machines. I really could care less about making stuff on the machines. And I don't know why. I think it's just because of the way things fit together and the structure that you have to build to make that happen. I'm not really sure on it. If I had to pick one machine right now, gun to my head, I would probably say my uh, my X-Carve router. It was a lot of fun to put together. I had a blast upgrading it and making it into this behemoth, like light industrial machine. This machine is a hobby machine. It's not supposed to run every day. It's made to hold a trim router, and somehow we've been able to build stone engraver for it, laser attachment for it, diamond engravers, end mills, ball end mills. We do 3D carving with it, 2D carving, 2D lasering. We do light stone engraving with it. I mean, it's just crazy what you're looking at, what you can see with it. And now I'm sitting back going, we're going to be getting a huge machine. And the first thing I'm going to do with it is make some workshop stuff and make some cabinets, some built-ins for our house. I'm going to bring it up on the screen. I'm going to be honest with you. This is just an amazing machine. Let's see what I've got here. Maybe I won't bring it up. How can I do this? We'll go here. We'll go all right. What I'm doing is I'm actually saving the pictures right now. And I'll pull those up for you. So this is our new machine. Check this thing out. If this isn't awesome, you know, you've got a full press formed metal structure underneath of it. You've got a full tie-in system, and it's aluminum extrusion with HGH 15 millimeter linear ball bearing guides, rack and pinion system. It's awesome. I posted some videos. I posted some real life photos of it on the Croft CNC and my personal pages. Here's the stats on it. This thing is going to be a beast, and the regular price on it's going to be $7,000. You know, with that you have add-ons like spindle upgrades, motor upgrades, controller upgrades, and stuff like that you can add on to it. But that's going to be the overall setup, and I can't wait. Think about that. 4 foot by 8 foot. I'll be able to make some major cabinets and stuff like that. So that is the new machine. Let me see if I can pull up some photos. And whenever we pull them up, I will man, this internet is slow today. I don't know what's going on. It's the end of the world. That's what it is. Let's see here. Do we have... Yeah, that one. We'll save that. Okay. Yeah, this will give you some ideas of what it looks like in real life. I mean, this thing is a beast, and I can't wait. It's supposed to ship, or it's supposed to be to me next week. Um, and I am super jazzed. I posted the videos of it running, rapiding around. It has proximity limit switches, rack and pinion. Look at that rack right there. That's what he said. Look at that rack. And then it's got a gear reduction setup that's built into the side panel, 1/2-inch thick aluminum side panels. It has a full reinforcement on the backside. It has wire trays and guide rails for the wires. This is a great light industrial advanced hobby machine from the looks of everything. So I can't wait to see what happens with it and see if we're on the right track. And I'm going to be upfront with you guys. I don't know what it's going to be like, but I have a feeling it's going to be awesome. So be on the lookout for that. So that kind of covers my favorite machines. Once again, I don't really have a favorite machine just because I like building them. I like building the machine. Let's see here. Taser's looking forward to some creations. Right on. Tim and Taser are going to like this. I think Tim knows what that is. I haven't found the other one yet, but as soon as I do, you might end up with two of them, one to put in a shadow box and one to put on your project. All right, let's see here. Today's topic for me that I wanted to get to was what are the machine differences in build? You guys hear me talk about hobby machines. You hear me talk about light industrial and industrial machines, and stuff like that. So I wanted to get into a little bit of the meat of that and what I mean by that. So my machine shop is set up where it is hobby machines and light industrial machines. Right on. I like that. I like where that's going. But the machines, their differences, they all operate very similarly. They have different control systems and they have different build qualities for the base. Okay. If you have a long, tall, but thin material structure for the base of the machine, you can get dipping. Okay. A prime example of that is the X-Carve. And I'm not knocking it. It is built for what it is intended to do, and that's to let you machine wood and plastics and stuff like that to get to know a machine. Like it's a hobby machine. It's a big expensive toy is what it is. But for me, I'm very much of the mindset that that machine can do so much more if you push it. We've got John on here. John has worked tirelessly on learning on an X-Carve because that's what he has. That's what he could afford, but he wants to do more. So I've walked him through ways to set up his speeds and feeds and everything like that. And now his machine, what was taking him 4 hours, is taking him 45 minutes, just by little things, learning the machines. So now when he is able to upgrade, he can buy a machine that has a pressed steel base that has angles in it to create a solid structure, but it still bolts together. So he's not taking up his whole shop for one machine. Okay. So the X-Carve, John says yes, and thank you very much. Absolutely, John. So the X-Carve falls into that entry-level hobby machine. That is not a downplay on what it is and what it's intended to do and what it can do. Okay. You guys have seen me upgrade that X-Carve from the base, very light machine to taking it to an intermediate advanced hobby machine where we've added braces, we've added riser plates, we've added a new Z-axis, we've made it direct drive, we've done anything and everything to this machine, right? The machine now cuts. I can take 150 inches per minute cut, an 1/8 inch deep in pine wood, no problem. You couldn't do that with the initial design of it. There were shortcomings in that design, but that design was what it was intended for. Fast forward to the PlasmaCam plasma machine. That is a pressed steel bolt together frame, and the gantry rides on 2 box tubing frame rails that are tied to the base. Okay. That is an advanced hobby light industrial machine. Okay. It has its shortcomings, but it has so much more. One of the things is their system uses servos with encoders, so it is a direct feedback to the software. Okay. They also have a proprietary software that gives feedback and throws errors, whereas the X-Carve is very limited on its errors and error buildup, resolution buildup. So you may lose steps and it doesn't know it, and your carve comes out a little off. Whereas when I'm cutting stuff on the plasma machine, it's not off. It can't be off unless I designed it off. Okay. I wrote the program wrong or anything like that, because it has closed loop feedback to the computer program. So the machine tells the computer where it's at. The computer says, okay, go ahead. That would be a advanced hobby machine / light industrial machine. The X-Carve right now, like I said, would be an intermediate to advanced hobby machine because it doesn't have closed loop feedback and it's operating on steppers. So we don't have that resolution feedback. Okay. We can still mess a lot of stuff up, and the machine's going to keep cutting and run itself into error without even knowing it. Okay. So now we take a step further and we go into the intermediate to advanced industrial machines. These are the machines you see. Like I built the one router with I-beams. Hold on one second. We got John's asking for that. I will explain that whenever we get to the project ideas. Okay. So The one router that I built was I-beams and steel box tubing, um, as the base to tie everything together. And what that does is, the stronger the base is, the less the machine itself can deflect, can bend and twist and everything like that. And what you end up with there is a strong base for the machine to actually ride on, that can't twist and bend and flex. And then from there, the actual structure of the machine is stout, and it uses it uses high resolution motors. It has feedback to the software and items like that, that you pretty much know where the machine is at in reference to the program. And that's kind of how that works in conjunction with everything. So yeah, that's basically it right there. The differences are construction materials, size of materials, thickness of materials for the base machine itself, and then software and hardware upgrades as you go through the system. Now, we did something with the X-Carve that made it very, very close to a light industrial machine by stabilizing the side rails to the base frame, mounting the base frame to a table, leveling the base frame, tying the side rails into that. And then whenever we put the gantry on and we expanded the gantry, we had such a long length that the gantry would actually bow in the middle. So as we cut across, you'd get a dip in the wood. It would actually dip from the edges to the center. So what we did with that was, we took the extrusion that's hollow in the center. It has a square tubing and it has reinforcements on the corners. The bends on the corners are really good. That keeps structural integrity from shifting around. But over the length of it, the weight would actually dip in the center. The way that we overcome that is we use a poly cement. So basically what we do is we mix a cement with an aggregate with an epoxy. Okay. And this has actually been done for quite a long time in the machine industry. You use this aggregate mix called poly cement, or polycrete, or anything like that. The aggregate is usually like a marble, a crushed marble, or some type of hard stone. The epoxy has no moisture to it, so it mixes with the cement. The cement hardens and solidifies all the pieces of aggregate to make like almost a solid beam inside of this extrusion. So if that extrusion is flat, then your extrusion fill will be flat, and you will have almost a solid steel structure similarity. Okay. And that's nice, because now we just took an entry-level machine that, at the end of the day, it cuts like 28 by 28. Okay. I've expanded mine. I can cut 48 by 48, which is a half a sheet of plywood. It's a 4 foot by 4 foot square. But we've been able to take that machine and expand it out on that system. One of the things that I have to do, the next upgrade to that, is the side plates and some type of motor feedback some type of encoder feedback to monitor what the steppers are doing. It's kind of a lost, not even a lost art. It's really not even anything more than I just want to do it just to do it and say I did it. Because at the end of the day, it doesn't really increase anything, do anything like that. Because it's a timing belt system. Whereas the other machines, like my plasma machine, is a rack and pinion machine. The new router is a rack and pinion machine. The lasers, they're timing belt setup, but they're more like printers. There's no real stress or strain on them, so you don't need anything more. So that's kind of that. Wow. Okay, so some other things for machine differences and builds. The X-Carve being a entry-level machine, an entry-level hobby machine, it has a drive system. The drive system are 4 to 6 wheels with a little V cut into them. And I'll pull that up right now. Let's see here. Let's see. Images. Okay. We're going to save this image. Okay. So let's go here, and we're going to save this image. And I'm going to bring that up on the screen for you guys right now. These are V wheels. Okay, so this is a V wheel. V wheel has a little V cut into it, and it rides on a pyramid-looking rail. Okay, they're not bad. They're not good. They transfer motion. Okay, that's what they do. The problem is the tensioning system on them is usually an eccentric nut. So you tighten that around, and whatever the tightness is what you get. Okay. That's kind of like the bottom of the barrel assembly setup, because if there are any thickness differences, then you have easy sliding spots and hard sliding spots. The more wheels you have over it, obviously, the more it's averaged out, but you still have it. Okay. Not the greatest assembly setup, but definitely an inexpensive option for you to be able to get started on. Another version of the V wheel is the Delrin wheels that ride in the openings of the extrusion. Okay, so that transfers. Basically, there's usually a motor mount here with a pulley on it. It has a belt that loops around and rides through. Okay, that's okay. That's okay. But some of the better systems, let's see if we can buy. Okay. Save as. Save as. Okay. On top of the structure, you have to think about the transmission system, and the transmission system is much better when you have the least amount of friction. So now if we translate that motion to something with ball bearings, these are linear guide rails, and they have lines of ball bearings that circulate, right? And they're greased, so they always slide real easy. It's separated out. You have more surface area and contact, so you don't have as much friction coefficient. So these slide much easier. This is what are on like the Haas machines, the Haas mini mills, the Haas CNC lathe, stuff like that. This is the transmission system. So they use like cast iron and an epoxy aggregate on top of these slides. Okay. And then they use really good motors and really good drives. That's what makes them a production machine. I mean, you can really knock out some stuff with the Haas mini mill. That is a great machine. And then this is what the linear rail looks like. So you would mount your machine table on this, and it would slide up and down. Okay. So we have belts versus lead screws, ball screws, and rack and pinions for power transmission. And then these are the motion transmission. Okay. So you have your drive transmissions, power transmission, and it goes timing belts, lead screws, ball screws, rack and pinion. Okay. All of them have their place. All of them have their pros, and all of them have their cons. Timing belts stretch. They're able to lose teeth and strip teeth. So they're not great in that aspect. The lead screws are good, but they need to have a constant adjustment on the backlash system to take up any deviation in the screw mechanism. Ball screws are actually the best, but the drawback to any screw system is as it spins, the longer the span, the more you get what's called screw whip. And that's where the screw itself, the screw mechanism itself actually starts spinning and whipping and vibrating and causing undue vibration in the machine. And that's where rack and pinion comes in because you mount the rack to the machine, and then it just has a cog that meshes with it and drives over long distances without any issue. Okay. That is the best long distance transmission, and most of the large format CNC routers and plasma tables and laser tables have that system, and they have a backlash mechanism set into it. There are helical gears and stuff like that. So this is a great motion transmitter. And then from there, we'll talk about CNC belt drives. Here's a great picture explaining the belt drive. And then we'll do Let's do a lead screw drive. Okay. We'll do okay. We'll do a ball screw drive. Okay. And we'll do a CNC rack and pinion drive. And I'm going to show you two of those, which is really cool. And we will do this and this. And then I'll show you a gear reduction setup. Like so. Okay, so I've got all my photos here. We're going to start bringing stuff up and we'll start talking about transmission of motion so that you understand what these timing belts and everything like that is. Let's see here. Okay, so we're talking about timing belts in CNC and how they mesh and everything. This is actually what drives the machine from the motor. Okay, it's very similar to a timing belt in a car with like a harmonic balancer and cogs to drive the power steering and everything like that. What we typically have is a plate that has wheels and bearings, and then there's a cog system right here, and whenever the motor turns on this cog, the belt moves in a similar fashion, and that drives this rack here forward and back. Okay, so an extrusion is mounted on here and drives it forward and back. The problem is whenever these belt teeth get worn, they break off and they lose that mesh, and with enough mesh they'll slip. Okay, you also have to adjust the tension on them to take up the stretch, because they're, even being Kevlar lined, they still stretch. So that's kind of bottom of the barrel decision. We then have a lead screw, and this lead screw design, you have just like a regular screw, you know, like a quarter 20 bolt. You have something similar to that. It usually uses like a Delron or an acetate low friction plastic to mesh with the screw. And it would look something like this. This is actually what's called a ball screw, and we'll explain that in a second. But that's the gist of it. Is you have your linear rail hidden under here, but then this screw is attached to the motor and a nut system here that drives, and then your gantry would be mounted up here, and it would just move forward and back or left and right or up or down. Okay, so that's kind of a lead screw, is kind of middle of the road system. It's very inexpensive to do, but it has a lot of loss of resolution, just like the timing belt. A ball screw, which actually is what I showed, I couldn't find a good lead screw picture that was different, but a ball screw, instead of having a screw that comes to a point, you actually have a rounded system This is the ridges are actually rounded over at the top, and then instead of having a triangular thread, they actually have a half round thread. Okay, and you can see it real good here. It's half round, and then it's rounded over here. And what that does is that helps alleviate a lot of friction by meshing ball screws, little ball bearings, into a circular feed. So what happens is these ball bearings feed through, they loop around, and they circulate. And the ball bearings actually circulate through this whole screw. Okay. The biggest problem you have with that is over long distances, this screw will actually start to jump up and down, creating vibration in the assembly. So if you don't have a nice, strong base, you'll get harmonic vibration, just like in a car motor. And everybody knows vibration is not good. The more vibration you get, the more chance there is for chatter. Okay. So that's actually the best method of transmission, but over long distances, it doesn't do well unless you have some type of stabilizer, and then you're getting into a whole bunch of stuff there that you really don't need to. But now we move into the rack and pinion systems, and the rack and pinion system is really cool. This is what the new router that I'm getting has, and it has a mesh gear on here. This is mounted to the motor and meshes on these teeth. Okay. So once it meshes on those teeth, it drives it, and you can span a long distance because this rack is mounted to the frame. These cogs are mounted to the motor, and that's what transmits the motion. Okay. So typically you'll have the gantry will ride on the linear rail system. And when it rides on the linear rail system, the rack and pinion system drives the system forward or back, left and right, up and down. Okay. This has a very poor transmission of motion because it has a lot of backlash, because all of these teeth have to mesh. And then as they start meshing and wearing, you get a lot of slop. So what they made to combat that was a helical rack and pinion. And this is kind of an understanding for industrial machines. This is a rack and pinion, but instead of being straight up and down, these are actually cut at an angle, and then the cog has opposite angled cuts, and they mesh in a helical fashion and take up a lot of the backlash. And then you could see the actual linear guide rail right here, and that has such a low coefficient of friction that it's almost like it just guides along. And then this motor is typically a gear reduced motor, and it's also a servo with feedback to the software. And what that looks like, this is a gear reduction. Let's see here. Okay. And open. Okay. So this is a gear reduction. And what that is the motor sits here with a cog. The belt on that cog goes over to this cog, creating a 3-to-1 or 2-to-1 or 4-to-1 reduction, whatever the mathematics work out based on the number of teeth on the belt and the cogs. And then on the inside of this cog is another cog, a smaller cog that meshes with this rack. So typically the cog on the motor and the cog on the rack are the same tooth count, but this cog creates, because it's a larger cog, it creates a 3-to-1 reduction, or a 2-to-1 or a 4-to-1 or a 5-to-1 reduction. And so it takes more spins to cover an area, but you get better resolution and you don't lose torque. So you have a lot more holding power to do what you have to do. All right. And realistically, power and speed are the name of the game. So, and that affects your feed rates and stuff like that. So those are kind of the motion aspects of things. The Haas mills and lathes, they use a ball screw system. It's usually a double ball screw that has a spring assembly that pushes the balls apart and pushes on each side of the ball screw, taking up the backlash. So you have damn near zero backlash. No system has zero backlash. It hasn't been able to be developed yet. This is as close to zero backlash as we can get. And then we utilize the software and the encoder feedback to say, oh, okay, here's where we're at. So the motor turns an encoder that then goes back to a microprocessor, and that microprocessor says, oh, you should have turned this far and moved this far, but you didn't move another 1/1000th forward or a 0.5 forward. The machine mechanism has to be able to have that resolution. One of the ways we can overcome that is, like when you're working with wood, you're using a hardwood that kind of retains some dimensional accuracy. Working in wood, if you can attain a 32nd of an inch, you are doing like phenomenal, right? Metal, if you can maintain like a 0.005, that's really good. Somebody like Titan Gilroy at Titans of CNC, they maintain like less than 1/1000. And the way they do that is they creep up whenever they make a pocket, they cut the center out, and then they creep up on the edge. And they may run that edge 4 or 5 times to just incrementally step over and make sure that they're moving in the same direction so that the backlash doesn't compound, because every time you move left and right, you're compounding your backlash. But if you move in a circle or a square all in one direction, you already took up that backlash and you don't have to compensate for it after that. But every time you change a direction, you introduce backlash into the system. That's the layman's terms of everything. Don't take that as gospel. Like I said, I'm trying to break it down for you and get you to understand where we're at with a lot of our machines and what we do. There's a lot to this. People don't understand when I build a machine, it's not as simple as, hey, I want a machine. It's what do you intend to do with it? How fast do you want to go with it? You have to make concessions on, if you have a budget, you have to sacrifice. If you have no budget, you get the best of everything. We'll use helical. You want a 5-foot by 10-foot machine. We're going to use helical rack and pinions. We're going to use servos with encoder feedbacks. We're going to use a software that then tells the servos, hey, go up to this resolution and move this far. I mean, we can go as far as you want to go with it as far as machine builders. It's a matter of, can your budget afford it? And if your budget can afford it, you're not having a machine built for you. You're actually buying an industrial machine that's already had all of that taken care of. And they have proprietary software that interacts with their specific setup, so on and so forth. For me, a lot of the stuff that I do, I use Mach 3 with servo feedback. And I tell the software, look, this is what I'm doing. This is how I want to take care of this problem. And I write little snippets of code to put into it, and the machine runs off of that software. But that's a universally accepted software. Okay. I just add my little touches to it. Now I can take that and I can make a custom interface for it, and now it's mine. So, you have a lot of companies that do that. They'll use Mach 3, but they'll put a custom screen on it so it looks like their own. It'll have their branding on it and stuff like that. But in the background in the software, it's actually just Mach 3 running, and they're just telling it like, this is the machine I built. This is how I built it. This is what the resolution is, and so on and so forth. All right, we got a comment. Does dual pressure enter into the picture on a router? Absolutely, Hammerhead. Tool pressure, both tension, compression, and deflection. All three of those enter into the equation when you're writing program, what your tolerances are, and what your speeds and feeds are going to be. So you guys hear me talk a lot about roughing and finishing and stuff like that. What we do is we use the biggest tool, the most aggressive tool we can, to hog out material the fastest that we can at the sacrifice of finish and resolution. Okay. So we might use a 1/4 inch 2-flute router bit, end mill bit, to hog out the center of an opening, a circular opening for a bearing. All right. We want to make some type of wood bearing plate. Okay. What we'll do is we'll hog that out real fast, real aggressive. Okay. It takes a lot of stress. It puts stress on the machine. It puts stress on the tool. It heats the tool up. The tool life isn't as long, so on and so forth. Okay. But we did it very fast. Okay. Then what we'll do is we'll run that same pocket, but we'll use a 1/4 inch single flute end mill. We'll move the speed down, and we'll just take a little 5/1000 cut. So what happens is, if you have material like this and the machine is pushing a tool into it, this is an end mill spinning. What happens is that machine is actually canting it like this. So what we do is we just sneak up on it, where we hammer into it and we really lay it over and we remove a lot of material, and then we'll soften that so that we just take a very light cut and just remove very little. And that's where yesterday's conversation of Titans of CNC Academy comes in, because that's exactly what they teach. That's what they do. They show you how to just kiss that edge. As Titan would say, you kiss that edge and boom, you got it. Okay. People don't realize that, like, this is all stuff you have to have up here, and you have to have hand knowledge of it. You don't just go into a machine shop with CNC machines and go, I want to make a square hole. You can't do that. Okay. What you do is you go in and you learn how to hog material, then you learn how to finish material, and then you learn how to be a professional and really sneak up and kiss that tolerance. Titans of CNC holds less than a thousandth of tolerance for the SpaceX project. You have to. Okay. So they have the best of the best machines. They have the best of the best software. They have the best of the best machinists. And all that comes together to make a SpaceX rocket. And that's a rocket that has went into space multiple times and comes back down. No space debris left out there. No worry of rockets and everything like that, being wasted, multi-million billion dollar assemblies being wasted. They're now able to go back through them, make sure all the tolerances are correct, make sure all the parts are correct, nothing's broken, and then send it back up again. Okay. So that's what goes into making this simple piece. You're making a simple piece. Why can't you just make this? Why can't you just make me a derby cover? I can make you a derby cover. It's going to be slow, it's going to be tedious, and it's going to cost you thousands of dollars because you want one custom derby cover with a custom shape on it and custom engraving on it. And what I have to do is I have to take a block of material like this, and I have to go back and forth, and I have to get a toolpath that carves that and then holds the tolerance. So now whenever I go up against this, I'm going to hog it out like that. I'm going to finish it out like that. And then I'm just going to kiss it so that it's the right tolerance. Every one of those, if I want an inch hole, I might hog it out to 7/8 of an inch. And that tolerance is so wobbly that it may be 15/16 of an inch before I have the hogging process done. And then I have to sneak up on that 16th of an inch. And then I have to do a finish pass on that. And all of that is predicated on does the tool go back to the same start point? And if it does, you're fine. But if you don't have the resolution or the feedback from the machine and those backlashes build up, now you're going, oh, okay. Now I'm getting something that's an 1/8 inch off, a 16th inch off, a 32nd off, whatever your resolution and backlash compensation may not have. That's what you have to do. So one of the ways to compensate for that as a machinist, what we will do is we'll have a start point. I know my X-Carve is a hobby grade machine. It's not going to have great feedback and it's going to have backlash in the system. So what I'll do in my program is I'll overshoot my start point. I'll make a new start point called a lead in. The machine will go back to that lead in, and then I'll come back and take up the backlash, and then I'll start my machining. Okay. So what I'll do is I'll home the machine so it's coming from the same point every time. And then I'll move forward, taking up the backlash to move to the part. And then I'll move to my starting point to take up that backlash. And I'll do that each time I have to make that part. And that's how we compensate for the backlash on hobby machines. The problem is hobby machinists don't know to do this, and they end up with something that's close but not quite right and stuff like that. And if you're a machinist that knows this, you're not going to have necessarily the hobby grade machine. You're going to have kind of like the light industrial. Okay. Another thing you can use are stop blocks and dial indicators to really dial in that system. I use Harbor Freight mills. right? I go up to Harbor Freight. I buy these mills for anywhere from $500 to $1,500. And then I mount dial indicators on them so that I know whenever I'm moving it, I'm moving the table, I'm taking up the backlash. So I'm going right back to where I was, and I take up the backlash that way. And it's a way to use manual digital readout is what we call it, manual readout. And digital readouts do the same thing, except for they use a glass scale and they put the numbers up on a screen for you. A dial indicator just has a dial and you have to read it. Okay. So there are a lot of aspects of machining that people don't realize, and they wonder why it costs so much. Well, it's because to do this, you have to have good material, you have to have good machines, and you have to have knowledge. You're not paying for the part, you're paying for all of that extra that goes into that part. And yeah, you might find somebody to do it cheaper. All I have to do is wait them out, because they're either going to underprice themselves and they're going to cost themselves their business, or they're going to give you something and you're not going to like it and you're going to come back to me anyways. Either way, I win. It's just a matter of, do I have to wait them out, or are you going to come back to me whenever you want the part done right? And that's it. And that was the big point of today's show. But some things that came up. John wants me to explain feeds and speeds, say for a 1/4 inch end mill. He also said this is great info, and a lot of people don't understand that concept. Absolutely. So project ideas for oak wood. We just got one in from Taser. Quality over quantity. Absolutely. It's just like a brotherhood. You don't want that guy that every Tom, Dick, and Harry wants, because everybody wants them because they're easy to get, right? You want the guy that is committed to being the best brother that they can be and fixing their shortcomings if they can fix them. And if they can't, you get rid of them, right? That's the way it goes. That's a very simplified version for those of you that are going to come back on me and all that. I understand we're not talking about that. We're trying to make an example. So, project ideas for oak. Oak is a very hard material, so it's structurally stable as far as wood goes. Some really good stuff is tabletops, table assemblies. 3D carves do really well in oak, and oak takes color very well. Okay. So, what I would do with oak is I would build with it and I would do 3D carves. I would stay away from doing your simple 2D carves, because you're not going to get the money out of it that you otherwise could get out of pine or something like that. But a lot of it depends also on what do you have in your area. Here in Pennsylvania, we have a lot of birch, black walnut, red oak, apple, cherry, sugar maple. All right. Different locations, maybe hemlock, maybe sycamore, maybe some cherry, some ash. Different places have different ecosystems, so you have different woods. We have a lot of oak here. As far as woods go, it's on the more expensive side, but it's not expensive in this area because it's so abundant. Down south, Florida area, they get a lot of cedar and cypress, and that's a piece of wood I would love to work with, is cypress. I have never ever carved a piece of cypress, 2D 2D surface finish, 3D carve, never. Um, so that's something I would love to get a piece of cypress in and play with it. So it really depends, as far as the projects go, what woods do you have in your environment, and what is the monetary standing of the people in your area. It does you no good to do a $5,000 3D carved wall panel when you live in a depressed, low income area, because there's not going to be the money to pay you to make that. You're actually, the way I look at it is, you're going to pay somebody to take your artwork. So you might as well, if you give them a $5,000 carve for $150, you might as well have taken $5,000, taken $150, put it in your pocket, and given them the remainder of the 5,000. That's how I look at it. Now, if you're in a financial district or something like that, where you have all these big wigs that have the big money, that want the nicer things in life, and it's all expendable, okay, you do the $5,000 wall carve, and then you upcharge it to $6,000. They buy it, they're happy, you made money, you're good to go. So there's a lot of factors that go into my theory of how I make something, or what I make. Sometimes I make stuff just to make it and show my skills, at which point I get whatever I get out of it, because I already got the value that I was seeking, and that was, I was able to video it, I was able to share it with people, I was able to teach myself, okay, next time I do this, I'm doing this differently, or I'm doing that differently, so on and so forth. So I keep trying to upgrade my skills, and in doing so, I just try stuff, and then I do a 3D carve. My first 3D carve I sold for $100. It was a 10-hour carve. You figure I get $60 an hour over 10 hours, and I sold it for $100. Okay. That was stupid. It seems stupid, but now I've got people coming to me saying, hey, can you carve me something like this? Can you make the file? Here's the 2D picture I want. Can you turn that into a 3D image? And can you carve that into a piece of wood for me? I've got people that say, hey, can you carve aluminum into a 3D shape for me? I want to put a aluminum plaque on my engine, or in my engine bay, and show it off at the car show. Can you do that? Yeah, we can do that. So you really have to find out what your area can take, what your perceived value of this project is. Am I making it to sell? If I'm making it to sell, I'm only worried about the money and the profit that I can get out of it. If I'm making it to challenge myself and educate myself, there really is no value assessment to it, because you're taking the journey as the value, and you really don't have any bearing on what you get out of it. Okay. If you're making something for the journey and trying to get money out of it, you're never going to get either. That's plain and simple. So if you have a lot of oak, depending on what the sizes are, if it's live edge or if it's finished, I would look at tabletops. I would look at maybe some epoxy pours, and I would look at 3D carves. That's where I'm at with it. That's what I would do. Then John had a question on feeds and speeds. That's a loaded question. I could do a whole week just on feeds and speeds, and I'm not even any good at it. You want to talk about feeds and speeds, you want to talk to Bob Warfield over at the what is it? The G Code Wizard. I got to check. He's over at the CNC Cookbook. Let me pull this up for you. G Wizard calculator. That's what it is. Okay. Bob Warfield made this website, and it is amazing. Okay. CNC Cookbook right up here. Okay. And it sets up, you basically set up your machines, you get a speeds and feeds, and it gives you a great, very, very close starting point. He also has a lot of tables and interactive interactive wizards that will write G code quickly for you. And then, you may not want to design a part. You may just want to say, I have 5 holes. They need to be spaced out on a 5-inch diameter, and they have to be 1/4-inch holes, and it'll write the G code for you. He also has a blog on his website, and his blog is awesome. Has a lot of good information. And then on top of it, he has different streams and calculators, and he has a bunch of free stuff. Now his goal is to get you to buy the calculator, so that's what you're getting geared towards. But he gets you to understand a lot of this. And you want to talk about a man that knows his stuff. This is it. You have, here's fixtures and jigs. And this is something that I'm obsessed with. I love fixtures and jigs, different mounts and stuff like that. And then this is just a step-by-step how to make a product. This is actually a picture from Ron Newman, this right here. And I thought that this was awesome, because I actually learned how to anodize from Ron Newman right here. He was in Danville, Pennsylvania. And that's where I learned how to anodize. And then after learning how to anodize, I learned how to chrome, stuff like that. So speeds and feeds, this is one of the big things that I use. But all in all, there are different calculators. I have a calculator on my phone. So if I go on here, I click in there. Let's see. There you go. And if I just go here and I put in my tool bit size, how many flutes it has, if I want it to be aggressive, normal, or conservative, and what my spindle RPM is, and then I tell it what material and hit calculate, it will spit out a beginning speeds and feeds in metric. And then I have to do a conversion from that. Mark Lindsay is a great resource too, John. John's got a bunch of messages coming through. Mark Lindsay is a YouTube content creator for CNC router items, and he does a great job. If you found Lindsay, use his information. You know, I have the utmost respect for anybody that puts out a video, even if it is the wrong information. They're trying to help, and they deserve credit for that. They also deserve to be educated themselves. Look, I get hate on some of my posts. I started refining gold and I started refining silver, and I have a family that brings gold and silver to me. Some of them are lockets and necklaces and stuff like that. And people are like, oh, they're stealing it. Well, how can you say that? Like, you don't know the family. You don't know where I acquired this or how. So how can you instantly say they're stealing it? What I know is the family collects gold. They buy gold from everybody, and then they want it brought in and made into an ingot of their own. So instead of having all this loose jewelry, they want gold bars. They want refined gold bars. So I learned how to do it. I followed a YouTube video series. I did it. I got great results out of it. The family took it and had it tested, and it's 0.999 pure gold and pure silver. So I'm getting it correct. Instantly, I posted it on Facebook, and instantly somebody said, oh, that's not the right way. Oh, they're stealing that and you're an accomplice. And it's like, no, I'm not. I know that they're buying it. They're paying for it. They're getting it from local people that come back to them and are like, hey, you know, I don't need this. I don't want this. I got divorced and I have no need for this ring anymore. You know, so I know where it's coming from. On top of that, they have different gold coins that are gold plated or silver plated, but it's a copper ingot in the center. It's not real gold or silver coinage. It's just a plating. Okay. You know, they have all these different like custom made coins and stuff like that. They're into that, and that's their thing. But then the process, somebody was like, oh, you're doing it this way and this way and this way, and you need to be using mercury. Well, why would I use mercury? Right? Does it work? Absolutely. But I kind of like being alive, and I kind of like my family not being in any danger. So, you know, everywhere you go, you're going to have people that are naysayers, and you're going to have people that are advocates. Remember that. Speeds and feeds, you're going to post your speeds and feeds, and somebody else is going to say, you could do faster, you could do better, you could do this, you could do that. Absolutely. I had a situation where a guy was asking about what is your longest carve. I did a Facebook Live on this. It was a 47-hour carve. It was a 21 inch by 18 inch wide, very intricate, took 4 tool changes, and the router ran. And that's what it did. And I was happy about it. And the way that it turned out, I was happy with that. But the guy asked the question, I posted about it, and then the guy that asked the question proceeded to tell me how wrong I was or how I wasn't doing this right or that right. My response was simple. You're probably better at speeds and feeds than I am. Congratulations. That's what works for you. I was happy with the results of mine. Could it have been different? Absolutely. Knowing what my machine is capable of now, when I did that, I think that I could probably take that carve and I could do that carve in probably about 11 hours. And that's sad to say, but that's what I could do because I have stronger motors. I have a better controller, and everything like that now. Now, the guy didn't ask about any of that stuff. He just said, what was your longest carve? It was 47 hours. Well, you're wrong. You could have done that. I don't give a shit. You asked, I told, and now you're degrading me. Thank you. You're probably much better at it than I am. Good job. I'll go sit in the corner and sit at the kids' table. Sorry. Didn't mean to answer you. And I get like that, and I explain because to me, instead of degrading me and telling me how I could have done it so much better, why don't you ask to see what the carve was? Because that's a loaded question. You have no idea how big the carve was. You have no idea what the carve was. You have no idea what my tool paths were. You have no idea why I decided to do it the way that I did it. You would look at Titans of CNC's tool pathing and you'd be like, why are you doing this in seven programs when you could do it in 3? You absolutely could do it in 3. But you're not going to hold the tolerance. And if you're not holding the tolerance, then what the hell's the point? That's what their journey is to hold the tolerance so that the spaceship can go up into space and move forward, right? So just keep that in mind. That's kind of a heavy question. It's a loaded question, and nobody is ever going to be 100% correct, because you'll have one professional that says do it this way and another professional will be like, he's an idiot, don't say that, don't do that. My thing is, just like from the very first episode, if it works, it works. That's it. If you get your end result, it works. Are there better ways to do it? Possibly. Is your way the end all be all? Probably not. But if it works and you're happy and it got you what you want, go for it. If you want to move faster and you want to pump out more product, start researching things and change your methodology. Done. Okay. For some of my bits, the feed is 85 plunges, 8.53. Okay. Absolutely. That doesn't sound outlandish. I would say, depending on what machine you have, which he has a stock X carve, that's pretty good. You could probably run it a little bit faster, but that's not putting a lot of stress and strain on the machine. And that's what we want. You're going to have your machine last a lot longer than what my machine will. My machine is not an X carve anymore, for the simple fact that I broke stuff and I increased stuff and I'm doing stuff that I shouldn't be doing with it. Your machine, on the other hand, is probably doing exactly what it's supposed to be doing, and you're doing a great job with it. So that's that. I got 6 viewers on here. Let's see. We've got 1 on business Facebook, 3 on personal Facebook, 2 on YouTube. Do any of you guys have any questions, comments, or concerns? John just popped in. I get my best results with those settings. Absolutely. You and I actually had a big conversation about this, and to me, that harkens to that conversation of, do test cuts, find out what your machine is capable of. Do what you feel comfortable with. You may not be comfortable running your machine at 250 inches a minute. That is stress on that machine. You're going to break stuff. You're going to break tools. You're going to ruin material. You're going to possibly ruin your machine. Me, on the other hand, I look at it as, this is what I paid for the machine. It's doing exactly what I need it to be doing, and that's showing people what it's capable of on the furthest limits and going from there. For me, I would probably be hogging out with like a 3/8 tool. I'd buy a collet that will fit 3/8. I'd use a 3/8 2 flute or 4 flute end mill, and I'd be running that pocket. If it's a 4-inch pocket, I'm going to run that thing at 250 inches a minute. I'm going to plunge it at 25 inches a minute, and I'm going to do a helical insert ramp in. I'm going to do a lead in, and I'm going to hog that thing out, but I'm going to leave myself an 1/8 inch wall. And then I'm going to come back with a nice 1/4 inch end mill. I'm going to clear out a lot of that 1/8 inch material. And then I'm going to come in with a 1/8 inch end mill. And I'm just going to kiss that edge so that I clean it up. I don't have any tapered walls. I don't have any shortness on the walls. I'm not over cutting the wall. It'll be a nice tight fit, and that's what you need. That's what you're going for. That's what people don't understand, is there's more than one way to skin a cat. Shit, I'm doing stuff. I do different parts for different machines on little mini mills that shouldn't be able to do the part. Why? Because I understand how to fixture it. And I'm fixturing it in such a way that I have one fixture that goes this way, and then I can locate it this way, and then I can move it horizontally and remount it and everything like that. I'm doing stuff on machines that shouldn't be able to do it. But it's because I've researched that aspect. And there are so many aspects to take into account that, you have guys like Titan that, man, he's pushing the envelope. Let me show you this. This is freaking amazing what this guy has accomplished. I'm going to go to YouTube. I'm going to pull up Titans of CNC. This right here, this titanium lion. This stuff, I mean, when you look at these machines, he's got hundreds of thousands of dollars.
Made some crazy parts, but none quite like this.
5-axis CNC machining in titanium.
You guys have seen me make all kinds of parts for different industries, but today we're doing it just because we can, to show you how these machines, they can make anything. So
he's 3D carving aluminum.
Let's do a lion.
It's stuff like this that absolutely amazes me the fixturing, the material, the tool usage. Now he's using coolant. I use air and mist coolant. He's using flood coolant, but his milling machine can handle that. That's what they do. And look, he's taking it section by section and doing exactly what you should be doing. And that's what people don't understand is quality over quantity. The best thing is if you can get quantity out of the quality. You know? But once it's all said and done, I'm just absolutely amazed at this. Look at this. That's out of titanium. And it's all because they understand how to do it. And that, my friends, is how I'm going to end this video. All right? Have a good one.